Hello there, and welcome to Drift to the Stars. I'm so glad you found your way here tonight. Wherever you are right now, lying down, curled up, somewhere quiet, or somewhere almost quiet, you made it here. That matters. This is a place with no rush and no urgency, just a voice and a sky full of things worth wondering about slowly together. And just before we begin, if these calm, curious explorations help you unwind, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, if you're ready, let's begin. Look up on any clear night, and what you see is not the sky as it is. It is the sky as it was. Each point of light left its source at a different moment, some hundreds of years ago, some thousands, some so long ago the word ancient barely reaches far enough. The night sky is not a single image. It is a mosaic stitched together from different pasts, each star arriving in your eye from its own private moment in time. You are not looking at the universe. You are looking at a museum of light, and every exhibit is a different age. The stars you see are real, but the moment you are seeing them in that moment is gone. What reaches you is only the record it left behind, traveling quietly across the dark until it found you here tonight. There is something almost tender in that. Closer in, very close in fact, something equally quiet is happening inside you. When you step outside into the dark, or when a room goes dim, the pupils of your eyes begin to open. They widen slowly, taking several minutes to fully adjust, and at their fullest, they reach nearly the size of a small pea. That seems almost too small to matter, but in that opening, something ancient stirs. The body is doing what bodies have always done, making itself as ready as possible to receive the faintest available light. It is not thinking about it, it simply knows. Your eyes right now are shaped by millions of years of creatures who looked up into the dark and needed to see. The pupil dilating in the night is one of the oldest gestures the body knows, and it is still happening in you quietly without being asked. The body always remembered the night, even when the mind forgot. Now hold a single thought gently for a moment. A photon, the smallest possible particle of light, leaves the surface of a distant star. It has no mass. It travels at the fastest speed anything in the universe can reach. And it travels for an almost incomprehensible amount of time before it does something extraordinary. It enters an eye. In your eye or someone else's, somewhere on this small planet, and in that collision, something in the brain stirs and registers it as brightness. The journey ends in a living thing, noticing a point of light. Scientists are still quietly moved by this, even when they do not say so. The light did not know where it was going. The eye did not know it was waiting. And yet the meeting happens again and again every night, every clear sky in every country where someone still looks up. Arrival after a journey longer than language has a name for. That is what seeing a star actually is. But between the stars, in all that space that looks simply dark, something else is happening. The gaps between stars are not empty. They are filled with extraordinarily thin clouds of gas and dust, hydrogen, helium, traces of carbon and water ice complex molecules, drifting in near-perfect silence. If you could gather all of it in one place, it would not seem like much. But spread across the vast distances of the galaxy, it adds up to the raw ingredients of everything that has ever been born out there. Scientists call it the interstellar medium. The name is precise, but it undersells the thing. This is the material from which stars form, from which planets coalesce, from which the conditions for life slowly, patiently arrange themselves. The dark between stars is not a void. It is a waiting room full of matter that has not yet decided what to become. The universe does not waste anything. It only lets things rest between forms. On the clearest nights away from city light, up on a hillside or out in a field, the human eye, unaided, without any instrument at all, can make out roughly 5,000 individual stars. 5,000. Counted and catalogued and named across dozens of cultures over thousands of years. Not 5,000 things, requiring explanation. 5,000 companions, familiar enough that ancient sailors used them to cross oceans, that farmers used them to know when to plant, that lovers used them to mark the hours of the night. They are not distant and cold, though in measure they are both. They are the oldest ceiling humanity has ever slept beneath. You do not need a telescope to be part of this. You need only a clear night and the willingness to let your eyes go soft and wide. The sky offers itself completely to anyone willing to be still enough to receive it. 5,000 stars, and every one of them has been seen before by someone who also needed the night. And yet, and here is where it quietly undoes you if you let it, some of those stars are no longer there. They burned out. They collapsed. They ended in one of the many ways stars end years or centuries or millennia ago. But the light they released before the end is still traveling. It had already left. There was no way to call it back. And so it continues its journey across space, carrying no message, carrying no warning. Arriving here on Earth looking for all the world like a living star, when in fact it is more like a letter from someone who is gone. Astronomers know some of them by name. They can calculate roughly when the light should stop arriving. But for now, those stars shine in our sky as brightly as ever. The body does not know the difference. The eye receives the light. Some goodbyes take hundreds of years to reach us. Right now, as you rest in whatever quiet you have found tonight, the light that left a particular star in the distant reaches of the galaxy is still on its way here. Not to Earth, not to this century. It will arrive long after every name you have ever loved, or spoken, or carried has passed out of all memory. You will not be there to see it. No one you know will. And somehow, if you let that land softly without resistance, it does not feel like loss. It feels like scale, like being reminded how deep the river is without being asked to swim it. The universe is not keeping track of us. It is simply continuing, and we are here briefly held inside it, watching. That is enough. That has always been enough. When you look up at the Milky Way on a dark night, that pale, soft river of light stretching overhead, you are not looking out at something separate from you. You are looking across the interior of the structure you are already inside. The Milky Way is our galaxy, and we sit within one of its outer spiral arms. What we see when we look at that band of light is the galactic plane, the flat disk of stars and dust seen edge on from our position within it. It is like standing inside a vast, slowly spinning coin and looking across at the far edge. You cannot step outside to see the whole shape. No human ever has, and none will in any foreseeable future. We know its form from mathematics, from observation, from the patient work of generations of astronomers building a picture piece by piece. 100,000 light years across, 200 to 400 billion stars, and you are in it. Not near it, not beneath it, in it. One small world, tucked into a quiet arm of a galaxy that does not know it is beautiful. Long before telescopes, long before any written record of the sky, there were people on open water. Polynesian voyagers, navigating across the largest ocean on Earth, used the stars not as decoration, but as a complete and working map. They knew which stars rose above specific islands. They tracked the arc of stars across the sky to determine direction. They memorized the behavior of swells of winds, of birds, and wove it all together with the stars into a system of navigation that allowed them to cross thousands of miles of open ocean and arrive deliberately where they intended. This was not guessing. It was knowledge built over generations, carried in memory, taught carefully from one person to the next. The stars were not mysterious to them. They were reliable. They were trustworthy. They were home in any direction. We did not lose this knowledge entirely. It was preserved, and it is still taught, and somewhere tonight, someone is learning to read the sky the way their ancestors did. There is something the night sky does that seems like one thing but is quietly another. Stars appear to twinkle, to flicker and shimmer, and dance especially near the horizon. It seems like a quality of the stars themselves, like they are breathing or pulsing with their own light. But the stars are not doing that at all. The stars are almost perfectly steady. What moves is our own atmosphere. Earth's air is constantly shifting layers of different temperatures and densities, sliding past each other, bending and refracting light as it passes through. Starlight arriving from incomprehensible distances in a perfectly straight line passes through all of that turbulence in the last few hundred miles of its journey, and it wobbles, it scatters slightly. It reaches your eye from slightly different angles from one moment to the next. The twinkling is us. It is the signature of our own imperfect, wonderful, life-giving atmosphere, wrapping the planet like a thin quilt and accidentally turning starlight into something that looks like it is winking. The stars hold still. The world around us trembles. And we call it beautiful because it is. There is a number that the mind cannot actually hold. Not really. It can say the words. It can nod along. But to genuinely feel the number of stars in the observable universe, to let it settle somewhere real, that is something else entirely. Astronomers estimate there are more stars out there than there are grains of sand on every beach and every desert on the surface of this planet. Every grain of sand on every shore you have ever walked. Every dune in every desert you have ever seen in a photograph. Every particle of sand at the bottom of every ocean, and still the stars outnumber them. And each of those stars is a sun, some smaller than ours, some almost incomprehensibly larger. Each one burning, each one ancient, each one surrounded by its own darkness and its own silence, and possibly, its own worlds. The number does not frighten once you let it settle. It does something softer. It makes the idea of being alone in the universe feel increasingly hard to believe. Loneliness at that scale starts to seem like a failure of imagination. There is a kind of star that has ended its life and collapsed not into a black hole, but into something almost more difficult to picture, a neutron star. What remains when a massive star dies is sometimes a sphere only about 12 miles across, roughly the size of a city. And yet, into that small space, the star has packed more mass than our entire sun. The matter inside is compressed so completely that electrons and protons are forced together into neutrons, packed almost as tightly as matter can be packed, just short of collapsing further. A single teaspoon of that material would weigh roughly as much as all of humanity combined. Not all of Earth, all of the people. In a teaspoon, the universe contains objects that the words we have do not quite fit. We reach for comparisons, a city-sized object outweighing billions of people, and the comparison lands but only partially. Some things can only be gestured toward, small on the outside, almost infinite in density within. The universe has its own kinds of stillness. Look up on a clear night and find the constellation Orion, or the Southern Cross, or the Big Dipper, or any of the shapes that human cultures have been drawing in the stars for thousands of years. They feel like clusters. They feel like neighborhoods of stars that belong together. They are not. The stars within a constellation are almost never near each other in any meaningful sense. They simply appear grouped from where we stand on this one small planet, at this one angle in space. The stars of Orion, for example, range from a few hundred to several thousand light-years away from Earth. They are scattered at wildly different depths, like lights at different distances down a long, dark road that from the front appears as a single cluster. The constellation is a drawing, a story we placed over the sky. Not wrong, never wrong, but a reminder that the shape of things depends entirely on where you are standing when you look at them. Change your position by enough, and Orion disappears entirely, replaced by a different pattern no human eye has ever seen. Perspective is not a flaw in vision. It is what vision is. 10,000 years ago, on a night very much like this one, somewhere on Earth, in a valley on a hillside, beside a fire, someone who could not sleep looked up. They saw the same stars, the same Milky Way, the same slow turning of the sky through the hours. They did not have the words we have, or the explanations, or the instruments, but they had the same eyes, the same widening pupils, the same quiet that falls over a person who stays still long enough for the sky to arrive. Whatever they felt looking up into that darkness was not so different from what moves through a person tonight. Wonder does not require vocabulary. The feeling of smallness, of being held inside something vast and indifferent, and somehow also safe, that is older than any language we have for it. You are not the first to lie awake and look. You are part of a line of watchers stretching back to the very beginning of what it means to be human. And that line has never broken. Not once. In the great stellar nurseries scattered through the galaxy clouds of gas and dust light years across, something remarkable happens when you look at the numbers. A nebula, one of those vast clouds where stars are born, can stretch across hundreds of light years. It can contain enough raw material to form thousands of suns, and yet if you were somehow able to step inside one and reach out your hand, you would feel nothing. The gas is so thin, so spread across such enormous distances, that in many places it is less dense than the best vacuum humans have ever created in a laboratory. Vast and almost empty at once. A birthplace made of almost nothing. Stars emerge from this extraordinary thinness, the way a thought emerges from silence, not suddenly, but gradually, over millions of years, matter pulling toward matter, warmth accumulating pressure, building until something ignites. There is no moment where the cloud becomes a star. There is only a slow process of becoming. The universe is patient in ways that make human patience feel like a brief held breath. Among the roughly 200 billion stars in the Milky Way, our Sun is not unusual. It is not especially large, not especially bright, not especially young or old. Astronomers classify it as a G-type main sequence star, a yellow dwarf middle-aged, burning steadily at a temperature neither extreme among stars. In stellar terms, it is ordinary. This used to feel deflating, perhaps. The center of our solar system, the source of all warmth and life on Earth, unremarkable. But the more you sit with it, the more it becomes a kind of comfort. We are not circling something exceptional. We are orbiting a common kind of star, the sort of star that turns out to be excellent for the slow, patient development of complex things. Not the flashiest, just right. Our Sun will burn for another 5 billion years or so before it begins to change. It is, by all accounts, in its comfortable middle years, steady, reliable, ordinary in the best possible way. There is something quietly reassuring about belonging to the unremarkable. Out in the universe, there is a type of star so extreme it makes a neutron star feel almost gentle. A magnetar is a neutron star with a magnetic field so powerful it has no comparison in ordinary life. If one were positioned at the distance of the Moon close, in cosmic terms, but still nearly 250,000 miles away, its magnetic field would be strong enough to disrupt the iron atoms in human blood. Not from radiation alone, from magnetism across that distance. There are only a small number of known magnetars in our galaxy. They are rare and they are quiet most of the time, relatively speaking. But occasionally, they release bursts of energy that travel across the galaxy and are still detectable when they arrive at Earth, diminished by the journey to something almost gentle. In 24 seconds, one magnetar released more energy than our Sun will release in 100,000 years. The universe contains things that are not built to any scale the body recognizes, and still the body is here small and warm, managing to exist in the same universe as a magnetar. That is worth noticing. Light moves at the fastest speed anything in the universe can travel, roughly 186,000 miles in a single second. That number is almost impossible to feel. In 1 second, light could circle the Earth more than 7 times. And yet at that speed, the nearest star beyond our Sun is still more than 4 years away. The center of the Milky Way is 26,000 light-years away. The nearest large galaxy is 2.5 million light-years away. And the edge of the observable universe is 46 billion light-years in every direction. At the fastest speed in existence, the universe is mostly unreachable. Not just difficult, not just far. Structurally, physically, fundamentally unreachable in any human lifetime, in any number of human lifetimes. The universe is not holding back. It is simply that large and light is simply not fast enough. There is a strange peace in that. Not everything needs to be reachable. Some things are enough just to know are there, burning quietly in the dark, at a distance that protects them from ever becoming ordinary. Here is something that is not a metaphor. The iron in your blood, the iron that carries oxygen from your lungs to every cell in your body, was not made on Earth. Iron cannot be made in a star like our Sun. It requires the extreme conditions of a much larger star, burning hotter and faster, fusing heavier and heavier elements, until it reaches iron, and then when it can go no further, collapsing and exploding in a supernova. That explosion scattered iron across space. Over millions of years that iron drifted. It eventually became part of the cloud of gas and dust from which our solar system formed. It became part of the Earth. It became part of the oceans. It became part of the first living things. It became part of you. When you press a hand to your chest right now and feel the steady, quiet beat of your heart, that rhythm is being kept by iron that was forged inside a dying star. Your body is an archive of the universe's history. You have been part of this story far longer than you have been alive. Jupiter does not announce what it does for us. It simply does it. The largest planet in our solar system, a world so vast that more than 1,300 Earths could fit inside it, sits in the outer part of the solar system and exerts a gravitational influence that shapes the entire neighborhood. Over billions of years, its gravity has captured or deflected countless asteroids and comets that might otherwise have made their way inward toward Earth. Astronomers debate the precise degree of Jupiter's protective role. It is not a perfect shield, and it has also at times nudged objects toward the inner solar system rather than away. But the general picture holds having a large planet in the outer reaches of a solar system may be one of the conditions that allows a small inner planet to remain stable long enough for life to develop. Jupiter has never known we exist. It has no intention toward us. And yet here we are, living quietly in the gravitational shelter of something enormous, something ancient, something that will still be here long after the sun has changed beyond recognition. Protection does not always know it is protecting. There is a sound the universe makes that no one can hear. Not because it is too quiet, because it is too slow. Certain stars breathe, they expand and contract in long rhythmic cycles, swelling outward over days or weeks before pulling back in, then swelling again. The motion is real and measurable. Astronomers call them variable stars, and some of them pulse with extraordinary regularity like a heartbeat kept across light years. If you could somehow convert that pulsation into sound, it would fall far below the lowest frequency a human ear can detect. A note so deep it would take weeks to complete a single cycle. The universe is playing music in a register so slow it feels from the outside like stillness. But it is not stillness. It is rhythm. It is the oldest kind of rhythm, a star breathing in the dark, expanding and contracting with a patience that makes seasons feel hasty. We discovered these pulsing stars and immediately used them to measure distances across the galaxy. Because their rhythm is so reliable, it functions as a kind of cosmic clock. Even in its breathing, the universe turned out to be useful. Even in its vastness, it offered something to hold on to. In 1977, two spacecraft left the Earth. Voyager 1 and Voyager 2, launched within weeks of each other, began journeys that are still continuing now. Voyager 1 has traveled farther than any human-made object in history. It has crossed the boundary where the sun's influence fades, and interstellar space begins a region called the heliopause, the true edge of our solar system's reach. And yet, the nearest star beyond our sun, a small, dim red dwarf called Proxima Centauri, is still roughly 70,000 times farther away than Voyager 1 has traveled. At its current speed, it would take Voyager 1 approximately 73,000 years to reach that star, if it were heading in that direction, which it is not. We sent something as far as any human object has ever gone, and it has barely left the neighborhood. The scale does not crush it, simply clarifies. The universe is not waiting for us to cross it. It is content to be what it is at the size it is on its own terms. Voyager carries a golden record with sounds from Earth, music, voices, wind, rain. Somewhere in the dark between stars, that record is still traveling, still carrying the sound of a thunderstorm on a planet it will never return to. If the entire history of the universe, all 13.8 billion years of it, were compressed into a single calendar year, the first stars would appear in January. The Milky Way would form in March. The Earth would not appear until mid-September. The first complex life on Earth would not emerge until December. The dinosaurs would arrive on December 25th and disappear on December 30th. And every human civilization, every city, every song, every war, every painting, every name ever written down would fit inside the last 11 seconds of the last day of that year. 11 seconds. Not to diminish what humanity has done inside those 11 seconds. Language, music, mathematics, medicine, kindness passed between strangers, all of it real, all of it mattering. But to hold it alongside the full year, even briefly, changes something. The urgency that fills ordinary days softens. The weight of small things lightens a little. You are here in the final seconds of a very long year, and the universe is not rushing you. It has nowhere else to be. Most of the stars you see at night appear to be alone, single points of light, solitary suns burning independently in the dark. Our own sun is like this, and for a long time it seemed natural to assume that was the norm. But it is not. Binary stars, two stars bound together by gravity, orbiting each other, are more common in the galaxy than single stars. Some estimates suggest that roughly half of all sun-like stars have a companion, and among larger, hotter stars, the proportion is even higher. Triple systems exist. Quadruple systems exist. Two suns rising, two suns setting. A sky where the shadows always have two sources, where the light on your face is always the light of more than one fire. Some planets in binary systems receive extraordinarily complex light, one sun overhead, another on the horizon, the day never quite the same twice. We grew up on a planet with a single sun, and it shaped everything about how we imagine warmth and morning and the quality of an afternoon. But out there, the single sun turns out to be the exception, not the rule. Most stars, it seems, prefer company. The galaxy leans toward togetherness. There is something in the universe that has mass, that has gravity, that shapes the movement of everything around it and that no one has ever seen. Dark matter does not emit light. It does not reflect light. It does not interact with light in any way that current instruments can detect. Its existence is inferred entirely from its effects, from the way galaxies rotate faster at their edges than they should, from the way light bends around regions of space that appear to contain nothing, from the large-scale structure of the universe that only makes sense if there is far more matter than we can account for. Roughly 85% of all matter in the universe is thought to be dark matter. The ordinary matter, stars, planets, gas, dust, everything we have ever seen or touched or measured makes up only about 15% of what is actually there. We are, in the most literal sense, a small, visible fraction of a mostly invisible universe. Science knows this, names it honestly, and continues looking. There is no shame in the not knowing. There is only the ongoing, patient work of asking better questions. The universe keeps more than it shows, but it leaves clues everywhere. After a star like our sun burns through its fuel, a process that takes billions of years, it does not simply go dark. It swells first into a red giant, then sheds its outer layers, and what remains at its core is a white dwarf, a dense, slowly cooling remnant about the size of the Earth, glowing faintly with leftover heat. A white dwarf cools incredibly slowly, so slowly that astronomers calculate a white dwarf could persist for longer than the current age of the universe, before fading to something they call a black dwarf, a cold, dark, inert remnant of a star. But here is the thing, no black dwarfs are thought to exist yet. The universe has not been around long enough for even the oldest white dwarfs to finish cooling. They are all still warm, all still glowing faintly somewhere out there in the dark stars that ended billions of years ago, still holding their last warmth like embers in a fireplace long after the fire is out. The universe does not let heat go easily. Even endings take longer than we expect. At the center of the Milky Way, approximately 26,000 light-years from where you are resting right now, there is a supermassive black hole. The light we see from that region of the sky left before our earliest human ancestors existed, before language, before tools, before anything recognizable as a human story had begun. That light was already on its way here, before the first word was ever spoken, before the first fire was ever lit, before anyone ever looked up and wondered what was there. And it arrived. It arrives every night. It reaches the eyes of anyone who looks toward the constellation Sagittarius on a clear, dark evening. Ancient light carrying no message, asking nothing, landing gently on the retinas of people who have no idea they are receiving it. The universe has been sending this particular light toward Earth for longer than humanity has existed. It did not know anyone would be here to receive it, and yet here you are in its path receiving it. Some arrivals were prepared long before the one who receives them was born. Right now, even as the rest of the world quiets around you, your eyes are doing something that every sighted creature has done since eyes first existed. They are turning toward uncertainty and attempting to make sense of it. In the dark, the eye searches, not anxiously, but instinctively, the way water finds a downward path. The brain, receiving less information than it is used to, does not panic. It settles. It softens. It begins to work in a different register, slower, more receptive, less analytical. This is one reason the night has always been a place where things become clear in a different way than daylight clarity. Not sharper, gentler. The nervous system, deprived of the constant stimulus of a bright world, turns some of its attention inward. The heartbeat slows. The breath deepens. Something that was held releases, without deciding to. You have been doing this your entire life. Every night, whether or not you noticed. The body knows how to receive the dark. It has been practicing for as long as you have been alive. And it is doing it right now. Stars are not born one at a time the way we sometimes imagine a single point of light emerging alone into the dark. They are born in families. In the great stellar nurseries of the galaxy, the Orion Nebula, the Eagle Nebula, the Carina Nebula, stars form in clusters dozens or hundreds at a time, pulled from the same vast cloud of gas and dust, by the same forces igniting within. Millions of years of each other, in what is, by cosmic standards, a single shared moment. Over time, the cluster disperses. The young stars drift apart as the galaxy slowly pulls them in different directions. After billions of years, siblings that were born together may be scattered across the galaxy, unrecognizable to each other, separated by distances that make reunion impossible in any meaningful sense. Our sun may have siblings, stars born from the same nebula, now scattered somewhere across the Milky Way. Astronomers have been searching for them, looking for stars with the same chemical signature, the same age, the same origin story. A few candidates have been found. Out there somewhere in the galaxy there may be a star that grew up alongside our sun. It does not know we are here, but the search continues. Beyond the familiar stars, beyond the nearby galaxies, somewhere behind the thick veil of dust and stars at the center of the Milky Way, there is something pulling. Astronomers call it the Great Attractor, a region of gravitational anomaly so massive that it is drawing our entire galaxy, along with thousands of other galaxies, toward it at enormous speed. The Milky Way, Andromeda, the entire local group of galaxies, all of them are moving in the same direction, pulled by something we cannot fully see because it lies almost perfectly hidden behind the densest part of our own galaxy. We know it is there from the motion of galaxies. We know roughly where it is. But its precise nature remains one of the open questions of cosmology. A gravitational center of something, a massive supercluster of galaxies, a knot in the cosmic web, its full face still obscured. The universe keeps some of its largest secrets behind the most ordinary-looking curtains. And the ground beneath everything, even the galaxy, is always quietly moving towards something. There is a story that ancient glass, the glass in old cathedral windows, is thicker at the bottom because it has slowly flowed downward over centuries, proof that even solid things are always moving. It is a beautiful story. It is also not true. Old glass is uneven because of how it was made, not because it flowed. Glass at room temperature is not a slow liquid. It is a solid, and it holds its shape across centuries without moving at all. But here is something that is true, and perhaps even more remarkable, inside certain meteorites. Rocks that fell from space. Some of them ancient beyond any earthly reckoning. There are tiny crystals that have remained chemically unchanged for 4.5 billion years, older than the Earth itself, older than the oceans, older than the sun had been burning when they formed. They are called presolar grains, microscopic minerals that condensed around other stars before our solar system existed, survived the formation of the sun, and the planets fell through space, landed on Earth, and were eventually found by patient scientists dissolving meteorites in acid to isolate what would not dissolve. A crystal smaller than a grain of sand, older than the world, held in a human hand, still unchanged. Some things endure not by resisting time, but by being so fundamental that time does not know what to do with them. Saturn's rings are one of the most iconic images in all of astronomy. Seen through even a small telescope, they look solid, like a disk, like a brim of a hat, like something structural and permanent. They are mostly empty space. The rings are made primarily of ice and rock, ranging from tiny grains to chunks the size of a house, all orbiting Saturn in a flat plane. But the gaps between those pieces are vast, relative to the pieces themselves. If you were somehow able to gather every particle in Saturn's rings and press it together into a single solid object, that object would be only a few miles across. The rings that span hundreds of thousands of miles would compress into something smaller than a modest mountain. What looks from a distance like a solid structure is up close almost entirely gap, almost entirely the space between things. Saturn's rings have been this way for perhaps 100 million years, and they will not last forever. The ice is slowly raining down onto the planet, drawn inward by Saturn's gravity. What looks permanent is temporary. What looks solid is mostly emptiness, holding its shape through motion. The appearance of solidity is one of the universe's most patient illusions. Hold your hand over your heart for a moment if you like. That beat, steady, quiet, keeping its own time, is made possible in part by iron. Iron that your body uses to build hemoglobin, the molecule that carries oxygen through your blood. Without iron, the blood cannot do its work. Without oxygen reaching every cell, nothing else is possible. And that iron was not made here. It was not made on Earth, not in the oceans, not in any geological process. Iron is the final product of nuclear fusion. In a massive star, the last element, a large star, can fuse before the energy required exceeds the energy produced. When the star reaches iron, it collapses. Then it explodes. And in that explosion, iron, along with many heavier elements, is scattered outward into space. Across millions of years, that scattered iron drifted through the galaxy. It eventually joined the cloud of gas and dust that became our solar system, became part of the young Earth, dissolved into the oceans, was absorbed by early life, and passed forward generation to generation until it arrived in you. The pulse beneath your hand is ancient. It is made of star death and slow time and the extraordinary patience of matter finding its way into a form that can notice things. Jupiter is not only large, it is large in a way that changes the arithmetic of the entire solar system. Its gravitational influence extends far beyond its own moons and rings out into the asteroid belt and beyond, nudging and shaping the orbits of countless smaller objects. Over billions of years, this influence has acted as a kind of gravitational shepherd, pulling some dangerous objects away from the inner solar system, capturing others as temporary moons, flinging some entirely out of the solar system altogether. The role is not perfectly protective. Jupiter has also at times directed objects toward the inner solar system rather than away from it. Scientists debate the net effect, but the general picture holds a large outer planet is likely one of the conditions that helps a small rocky inner planet remain stable over geological timescales. In 1994, astronomers watched as the comet Shoemaker-Levy 9, broken into more than 20 fragments, crashed into Jupiter over the course of 6 days. Each impact left a scar in Jupiter's atmosphere larger than the Earth. Had those fragments continued inward, the story of this planet might have been very different. Jupiter absorbed that, the way a large and quiet thing absorbs what a smaller thing could not survive. It did not know what it was doing. It simply had the mass for it. In the very first moments after the universe began, not years, not centuries, but in the first few 100,000 years of time, the universe was too hot for light to travel freely. Matter and energy were so densely packed and so intensely hot that photons could not move more than a tiny distance before being absorbed and re-emitted. The universe was opaque, like a fog so thick that nothing could be seen through it. Then, as the universe expanded and cooled, something changed. Electrons slowed enough to be captured by protons, forming the first hydrogen atoms. And suddenly, light could travel. It streamed outward in all directions, the first light ever to move freely through space. That light is still traveling. It has been traveling for nearly 13.8 billion years, cooling as the universe expands, stretching from visible light into microwave radiation. It now fills all of space equally in every direction, a faint and uniform glow called the cosmic microwave background. It can be detected today. It was accidentally discovered in 1965 by two engineers who noticed an unexplained hiss in their radio antenna and could not identify the source, not knowing they were hearing the oldest light in the universe. The echo of the moment everything became visible. The first light is still here, still arriving, still filling the space between everything. In our solar system, Io is not a place of stillness. Io is the innermost of Jupiter's 4 large moons, and it is the most volcanically active body in the solar system, more volcanically active than Earth, more than any other world we have found. Its surface is covered in sulfur and silicate rock, constantly being repainted by eruptions that some observers have been able to detect from Earth with the right instruments. The reason for all this violence is gravity. Io sits between Jupiter and the other large moons, pulled in multiple directions simultaneously. This gravitational tug-of-war flexes and heats Io's interior the way bending a metal rod repeatedly heats it. The result is a world that is constantly being remade. Volcanoes here do not erupt occasionally, they are nearly continuous. The oldest features on Io's surface may be only a few thousand years old. In a solar system where most solid worlds are ancient and largely unchanged, Io is startlingly alive. Its surface is being written and rewritten in real time, a world with no memory of what it looked like before. Some places do not hold their shape. They are always becoming something else. If you were to look at a map of the large-scale structure of the universe, galaxies and galaxy clusters, plotted across hundreds of millions of light-years, what you would see is not a uniform distribution of matter. You would see something that looks unmistakably like a web. Long filaments of galaxies stretch between vast, nearly empty voids. Where filaments intersect, great clusters of galaxies gather. The pattern repeats at enormous scale, a foam-like structure, a network, a lattice of matter suspended in emptiness. Scientists call it the cosmic web. It is the largest structure ever mapped, and it bears a resemblance, noticed by researchers who were not looking for it, to the network of neurons in a human brain, the same branching, the same clustering at nodes, the same vast empty spaces between. No one claims the universe is conscious. No one is suggesting the cosmic web thinks. But the resemblance is not nothing. It suggests that the mathematics of growth and connection, whatever the scale, whatever the material, may produce similar shapes. That the pattern which connects your thoughts is related in some deep structural way to the pattern that connects the galaxies. The shape of a mind and the shape of the universe rhyming quietly across every scale of existence. Here is one of the most honest things science has ever said. We do not know why there is something rather than nothing. More specifically, the universe appears to contain more matter than antimatter. When matter and antimatter meet, they annihilate each other completely, converting entirely to energy. In the first moments after the beginning of the universe, matter and antimatter were produced in almost equal quantities. Almost. There was a tiny imbalance for roughly every billion pairs of matter and antimatter particles. There was one extra matter particle. That one extra particle per billion is why everything exists. The antimatter annihilated with the matter. The energy was released, and the tiny remainder, 1 in a billion, became every star, every planet, every ocean, every cell, every thought you have ever had. Scientists do not yet know why that asymmetry existed. It is one of the deepest open questions in physics. You exist because of an imbalance so small it almost was not there. and no one yet knows why that imbalance was there at all. That question does not need an answer tonight. It is enough simply to hold it gently and let it remind you how extraordinary ordinary existence actually is. Between the galaxies in the vast stretches of space that appear at first to be simply empty dark, there is a faint glow. Not visible to the naked eye, not even easily detected by most instruments, but present. The intergalactic medium is not perfectly dark. It is permeated by a faint ultraviolet background radiation left over from the era when quasars, extraordinarily luminous objects powered by supermassive black holes, were at their most active, flooding the young universe with intense radiation. That radiation has faded as the universe aged and quasars quieted, but a remnant of it still fills the space between galaxies, invisible but real, a kind of afterglow from the universe's most intense and brilliant period. The universe was once far more luminous than it is now. It has quieted over billions of years the way a fire slowly becomes cold, still warm, still glowing, just more gently than before. What we think of as the dark between galaxies carries the memory of a time when the universe was blazing. The darkness is not absence, it is aftermath. Even empty space remembers what it held. Beneath the frozen surface of Europa, one of Jupiter's moons, a world slightly smaller than our own moon, there is almost certainly a liquid ocean. Not a small one. Scientists estimate it may contain twice the volume of all the water in all of Earth's oceans combined. It is kept liquid not by sunlight. Europa receives very little of that so far from the sun, but by tidal heating, the same gravitational flexing that drives Io's volcanoes, working more gently on Europa's interior, keeping the subsurface ocean from freezing solid. Beneath the ice in the dark, warmed from below it, is one of the places in the solar system considered most likely to harbor some form of life. Not confirmed, not proven. But the conditions are, by everything we understand about life on Earth, not unpromising. A hidden ocean twice the size of all our seas in the dark beneath the ice of a moon of Jupiter. Possibly warm at the bottom where the ocean meets the rock. Possibly not alone. The search for life beyond Earth may not require looking very far at all. It may require looking down through the ice, into a dark and patient sea, very much closer to home than anyone once imagined. In 1995, astronomers made a decision that many considered either brave or foolish. They pointed the Hubble Space Telescope at a patch of sky near the handle of the Big Dipper, a region that appeared completely dark, containing no known stars or galaxies, chosen specifically because it seemed to contain nothing at all. They kept the telescope pointed at that emptiness for 10 consecutive days, collecting every photon that arrived from that direction. The resulting image, now called the Hubble Deep Field, revealed 10,000 galaxies, each one a collection of hundreds of billions of stars. Each one an entire universe of worlds in a patch of sky the size of a grain of sand held at arm's length. 10,000 galaxies in the nothing. The image changed something permanent in how astronomers and eventually the rest of humanity understood the scale of what exists. The universe is not mostly empty with occasional islands of matter. It is full, unimaginably, overwhelmingly full. Every direction, to every depth that any instrument has ever looked, there is more. Empty sky is not empty. It is only empty as far as we could see before we looked harder. And every time we have looked harder, we have found more. The universe has never once disappointed a patient eye. Venus is, in many ways, Earth's twin, nearly the same size, nearly the same mass, made of similar materials, formed at roughly the same time. From a distance, it might seem like a second chance, a second home, a familiar world. Up close, it is one of the most hostile places in the solar system. The atmosphere of Venus is nearly 100 times denser than Earth's, composed mostly of carbon dioxide, with clouds of sulfuric acid. The surface temperature sits at roughly 465 degrees, hot enough to melt lead, hot enough to destroy most metals within hours. The pressure at the surface is equivalent to being nearly a kilometer underwater in Earth's oceans. And here is the detail that quietly stuns Venus. Rotates so slowly that a single day on Venus One full rotation takes longer than a full year on Venus. It completes an orbit around the Sun before it completes a single turn on its axis, and it rotates in the opposite direction from most planets, so the Sun, when it is visible through the clouds, rises in the west and sets in the east. A world almost identical to ours and almost perfectly uninhabitable. The same ingredients assembled differently can produce something almost unrecognizable. You carry, inside you, the remnants of events that happened before the Earth existed. The copper in your body, in your nervous system, in the enzymes that help you breathe, was made in the heart of a massive dying star and scattered outward in its explosion. The gold in old jewelry, if you have ever held a piece, was formed in the collision of two neutron stars, one of the most violent events the universe produces. The iodine your thyroid gland needs to regulate your metabolism was also forged in stellar explosions and distributed across the galaxy over billions of years. Every element heavier than iron in the periodic table was made in the deaths of stars or the collisions of their remnants. The universe had to die repeatedly and violently to produce the conditions for something as quiet and specific as a living body. You are not made of stardust in a vague, poetic sense. You are made of the specific products of specific stellar events elements, with histories forged under conditions that no laboratory on Earth can replicate, delivered across billions of years and unimaginable distances to end up here in this particular arrangement, breathing quietly in the dark. The universe is expanding. That much has been known since the early 20th century, when astronomers first noticed that distant galaxies were moving away from us in all directions. The universe, like a slowly inflating sphere, is growing, carrying galaxies with it, stretching the space between them. But in the late 1990s, two independent teams of astronomers, studying a specific type of stellar explosion used as a cosmic measuring tool, found something they did not expect and initially did not want to believe. The expansion is accelerating. The universe is not just expanding, it is expanding faster and faster, driven by something that fills all of space uniformly, pushing everything apart with a force that grows as space grows. Scientists named it dark energy, a placeholder name for something they do not yet understand. It makes up roughly 68% of the total energy content of the universe. It is the dominant feature of the cosmos, and no one knows what it is. This is not a gap that will be filled by next year's research. It is a genuine, deep, structural unknown, the universe's most present and pervasive ingredient, invisible, unmeasured in any direct sense, known only by what it does. The universe is mostly made of something we cannot explain, and it is accelerating away from itself and from us in every direction right now. At the edge of the solar system, farther out than Neptune, farther out than the dwarf planets and the scattered disk of ice and rock, there is a region that has never been seen directly. The Oort cloud is a vast, roughly spherical shell of icy bodies, thought to surround the solar system at an enormous distance, beginning perhaps 2,000 times farther from the Sun than the Earth is, and extending perhaps a quarter of the solar system, way to the nearest star. It is thought to contain trillions of icy objects, the frozen remnants of the early solar system, preserved in the cold and the dark. We have never photographed it. No spacecraft has come close to it. Its existence is inferred almost entirely from the behavior of long-period comets, comets with orbital periods of hundreds or thousands of years, whose paths trace back to that distant region, suggesting they were disturbed from their resting places there by the gravitational influence of a passing star or the slow tidal pull of the galaxy itself. The Oort cloud is the most distant part of home, a shell of sleeping ice around everything we have ever known so far, a way that the Sun from there would appear as nothing more than a bright star among many. Even the edges of the familiar turn out to be almost impossibly far. On a night when Pluto was still considered the outermost planet, before it was reclassified, before we had seen its surface in any detail, it was simply a point of light, a number in an equation, a world no human instrument had ever photographed up close. Then in July of 2015, the New Horizons spacecraft, launched nearly a decade earlier, traveling at speeds that make most human reference points useless, flew past Pluto and sent back images. there was a heart, not metaphorically. On Pluto's surface, a vast pale region shaped unmistakably like a heart, now named Tombaugh Regio. Within it, a nitrogen glacier, a slowly flowing plain of frozen nitrogen reshaped by convection from below, constantly and slowly stirring itself a living landscape of ice on the edge of the solar system. Pluto, at the dim and freezing edge of everything familiar, turned out to have weather, to have geology, to have a surface that moves and changes. It turned out to be a world, not a number. The universe keeps saving its surprises for the moment you get close enough to actually look. There is a planet orbiting a star not far from the center of our galaxy, discovered, catalogued, studied, that reflects almost no light at all. It is called informally a hot Jupiter, a gas giant, orbiting very close to its star, tidally locked, one face, always in blazing heat, the other in permanent night. Its atmosphere absorbs nearly all the light that strikes it, reflecting back less than 1%. If you could place it in our sky, it would be almost invisible even in full sunlight. Blacker than coal, blacker than any natural material found on Earth. A planet that drinks light and gives almost nothing back. Astronomers found it not by seeing it directly, but by measuring how much the star's light dimmed as the planet passed in front. A shadow within a shadow, detected by instruments measuring fractions of a percent of change in a sight. Star's brightness from light years away. We found it by noticing an almost imperceptible absence, a world revealed not by what it showed but by what it hid. So many things in the universe are known this way, not by their light but by the shape of their darkness. Close your eyes for a moment if they are not already closed, and imagine a sound coming from somewhere very far away. Stars are not silent. They vibrate, oscillating in complex patterns, ringing with tones produced by the movement of sound waves through their interiors. The field that studies this is called asteroseismology, and it has taught us more about the inside of stars than any other method, because just as geologists use earthquakes to understand the interior of the Earth, astronomers use starquakes to understand the interior of stars. The tones stars produce are real. They can be translated into audible sound, sped up enormously from their natural frequencies. Our own sun rings with thousands of overlapping modes of oscillation, simultaneously, a chord played continuously for billions of years. You cannot hear it. The sound does not travel through space, and even if it did, the frequencies are far too low for the human ear. But it is there. The sun is singing right now in frequencies your body cannot receive, but your instruments can translate. The universe is not quiet. It only sounds that way from here. Saturn has 85 known moons. Among the largest is Titan, a world so strange it seems borrowed from a different solar system entirely. Titan has a thick orange atmosphere, denser than Earth's. It has weather. It has a water cycle, but not with water. On Titan, methane plays the role water plays on Earth. Methane evaporates from the surface, forms clouds in the atmosphere, falls as rain collects in lakes and rivers and seas on the surface, and slowly evaporates again. The lakes of Titan are filled with liquid methane and ethane. They are cold enough, nearly 200 degrees below zero, that they feel nothing like the lakes you know. There is no warmth in them, no light worth calling light. The sun from Titan's surface is a pale, distant smear 760 million miles away, giving almost no heat. And yet, it is a world with a cycle, with seasons, with something that functions structurally, like the familiar patterns of rain and river and sea, just made of entirely different materials, in entirely different conditions, under an entirely different sky. The universe seems to like certain shapes. It returns to them again and again in whatever materials happen to be available. Beyond the orbit of Neptune, beyond Pluto and the other dwarf planets, there is a vast region called the Oort cloud. But even before that, wrapping around the solar system like a distant second skin, there is the Kuiper belt. And beyond that, the scattered disk full of icy bodies in elliptical orbits, occasionally perturbed inward by the gravity of the outer planets. From these distant reservoirs come the long-period comets, visitors from the outermost edges of the solar system, falling inward over journeys that take hundreds or thousands of years, developing their luminous tails as the sun's warmth begins to vaporize their ice, burning briefly bright, before swinging around the sun and returning to the dark. These comets carry water, ice, and complex organic molecules. Amino acids, the building blocks of proteins, have been found in comet material. The hypothesis still being tested, still uncertain, is that Earth's water, or some portion of it, arrived on the back of comets and asteroids in the early solar system billions of years ago, long before anything lived here. If that is true, then the oceans you have seen or imagined, the water in every river, in every cloud, in every cell of your body, may have come from space, may have traveled across the solar system on a slow, cold journey before finding a warm world to rest on. Water remembers where it came from, even when we do not. Long before anything lived on Earth, before the oceans had fully formed, before the crust had cooled enough to hold a continent in place, comets were falling. Not catastrophically, not all at once, but steadily over hundreds of millions of years, in what astronomers call the Late Heavy Bombardment. A period when the inner solar system was being pelted by debris left over from the solar system's formation, nudged inward by the shifting orbits of the outer planets. Those comets and asteroids carried water ice. They carried organic molecules, carbon compounds, amino acids, the chemical precursors to the molecules of life. They delivered these things to the young Earth, the way a slow, patient river delivers sediment gradually over immense time, building something in the accumulation. Whether Earth's water came primarily from comets or from water-bearing asteroids is still debated. The answer may be a combination of both. But the possibility that the ocean outside your window, or the one you are imagining right now, arrived from space carried across the solar system on frozen rocks before anything alive existed to receive it, sits quietly in the current literature as a real and serious scientific hypothesis. The world was built from what fell into it, and some of what fell came from very far away. Mars is a quiet world now. Its volcanoes are dormant. Its magnetic field is gone. Its atmosphere is thin enough that liquid water cannot persist on its surface, evaporating almost instantly in the low pressure. But when a dust storm comes, Mars is anything but quiet. Martian dust storms can grow to cover the entire planet, all 144 million square kilometers of it, within weeks. The sky turns from its usual butterscotch pink to a deep, murky amber. Sunlight is reduced to a fraction of its usual strength. The temperature drops. The dust, so fine, it behaves more like smoke than sand, can remain suspended in the atmosphere for months before settling. In 2018, a global dust storm lasted long enough to end the mission of the Opportunity rover, a machine that had been operating for nearly 15 years, far beyond its intended 90-day lifespan, brought finally to silence, not by mechanical failure but by darkness. Its solar panels could not gather enough light. It sent its last signal and went quiet. A machine that lasted 15 years on another planet ended by a storm of fine red dust blocking out the sun. There is something in that story that feels old and familiar, even on a world no human has ever stood on. Even on Mars, the weather wins in the end. There is a fact about living things on Earth that tends to produce a long silence when it fully lands. You share roughly 50% of your DNA with a banana, around 60% with a fruit fly, around 85% with a mouse, around 98.7% with a chimpanzee. These numbers are not approximate poetry. They are the result of genetic sequencing, the careful letter-by-letter comparison of the chemical code inside cells. And what they show is that every living thing on Earth is related, not distantly, not metaphorically, genuinely biochemically, structurally related, tracing back through an unbroken chain of ancestors to a single common origin, a single living cell or community of cells that existed somewhere between 3 and 4 billion years ago. We do not know exactly what that first ancestor looked like. We call it Luca, the last universal common ancestor, and it is inferred from the features shared by all life that has ever been studied. It had DNA. It had ribosomes. It had a version of the metabolic processes that still run in your cells right now. Every living thing you have ever seen, every tree, every bird, every whale, every bacterium in the soil is your relative. The family is larger and older than any story has ever managed to hold. On certain nights in certain latitudes, the sky does something that stops people mid-sentence. The aurora, the northern lights, or the southern lights, depending on where you stand, appears as curtains of green, sometimes red, sometimes purple, moving slowly across the upper atmosphere like something alive. People who have seen it often say it does not look real. It looks, they say, like a painting, like something placed there deliberately. It is caused by charged particles streaming outward from the sun, the solar wind interacting with Earth's magnetic field. The field funnels these particles toward the polar regions, where they collide with oxygen and nitrogen in the upper atmosphere. Those collisions release energy as light. The green comes from oxygen at lower altitudes, the red from oxygen higher up, the blue and purple from nitrogen. Earth's magnetic field is what makes this possible, and it is also what makes the aurora a kind of visible proof that the planet is protected. The same field that paints the sky with light is the shield that deflects the most harmful solar radiation from reaching the surface. The aurora is not just beautiful. It is the light of the shield itself made briefly visible. The planet showing you in color what it does for you every day without announcement. Out among the stars, there are suns so large that the word large stops working properly. The star UY Scuti, one of the largest known, has a radius roughly 1,700 times that of our Sunday. If it were placed where our Sun is, its surface would extend past the orbit of Jupiter, swallowing Mercury, Venus, Earth, Mars, the asteroid belt, and most of the distance to Saturn. Our entire world and everything anyone has ever known would exist inside that star. And yet from Earth, even with a telescope, UY Scuti is a faint point of red light, not even particularly notable among the stars in that region of the sky. The difference between a star the size of our Sun and a star 1,700 times larger is from the distances involved nearly invisible. Scale is one of the places where the universe consistently exceeds the imagination. Not because the imagination is weak, but because the universe is genuinely structurally beyond what the mind evolved to hold. We evolved to navigate a world of trees and rivers and distances measured in days of walking. The universe does not fit that scale. It was never trying to. And somehow that is not a failure. It is an invitation. In the beginning, in the very first generation of stars, the universe had almost nothing to work with. Hydrogen, helium, tiny traces of lithium. That was essentially the entire periodic table available to the first stars. No carbon, no oxygen, no iron, no silicon. None of the elements that make rocky planets possible, that make chemistry interesting, that make biology conceivable. Those first stars burned hot and fast, far larger and more energetic than most stars today, because without heavier elements to help regulate their internal processes, they ran on raw fuel with nothing to slow them down. They lived for only a few million years, brief by stellar standards, and then they died in enormous explosions. And in those deaths they made everything else. Carbon, oxygen, nitrogen, silicon, iron, forged in the cores of those first massive stars and scattered outward into space, seeding the universe with the ingredients for everything that followed. Every subsequent generation of stars formed from clouds already enriched by the deaths of those first ones. Our Sun is a third-generation star. At least its material has been through previous stellar lives before arriving here. We are downstream of those first deaths. Everything we are made of was a gift from stars that burned out before the Earth existed, passed forward like something placed carefully in the hands of whatever came next. Every breath you take right now is in a quiet and literal sense borrowed from the distant past. The oxygen in Earth's atmosphere was not always here. The early Earth had almost none of it. For the first 2 billion years of life on this planet, the atmosphere was dominated by nitrogen, carbon dioxide, methane, a sky that no human lung could have survived. Then, roughly 2.5 billion years ago, a type of microscopic organism called cyanobacteria developed the ability to perform oxygenic photosynthesis, to split water molecules using sunlight, and release oxygen as a byproduct. They did this not as a gift. They did it because it worked for them. But the oxygen they released accumulated in the atmosphere over hundreds of millions of years, in what geologists call the Great Oxidation Event, transforming the planet's chemistry, killing many organisms that could not tolerate it, and making possible the evolution of everything that breathes. The oxygen entering your lungs right now was exhaled in the most extended sense of the word by organisms that have been gone for billions of years. Your breath is continuous with theirs. The atmosphere is a kind of inheritance passed forward without intention, received without acknowledgement. You are breathing the ancient work of creatures so small they are invisible, so old they predate every animal that has ever lived. It takes 8 minutes for light to travel from the surface of the sun to the earth. 8 minutes, a short enough time to feel almost immediate, almost close. But inside the sun, before that light ever reaches the surface, it takes something vastly longer. Energy generated in the sun's core by nuclear fusion begins its journey outward through a region called the radiative zone, a dense layer of plasma where a photon cannot travel more than a fraction of an inch before being absorbed, re-emitted in a random direction. This random walk through the solar interior is extraordinarily slow. A photon generated at the sun's core today may take between 10,000 and 100,000 years to work its way to the surface, absorbed and re-emitted countless times along the way. Then it leaves the surface and crosses 93 million miles to Earth in 8 minutes. The warmth on your skin on a sunny afternoon has been traveling outward through the sun for longer than modern humans have existed, released finally, crossing the void, quickly landing on you in the last 8 minutes of a journey that began before the first cave painting was ever made. Light is both fast and infinitely patient depending on where it is. Somewhere out in space, expanding outward from our planet in a slowly growing sphere, is the full record of human radio transmission. Every broadcast, every radar pulse, every television signal, every communication sent through the air since the early 20th century has been leaking outward into space at the speed of light. The oldest of these signals have now traveled roughly 100 light-years from Earth. They are passing through a region of space containing several thousand known stars. The signals grow weaker with distance spreading across an ever larger sphere of space. They thin out rapidly. By the time they reach even the nearest stars, they are extraordinarily faint, far below the threshold any known technology could be expected to detect. The universe does not receive us clearly, but we have been broadcasting unintentionally for over a century. The first radio signals from Earth's early broadcasts of music and voice and news have already reached thousands of star systems. Most of those signals carry nothing that could be decoded, but they carry a pattern, a regularity, a signature that says to anyone with the right instruments and the patience to look, something here has learned to use electromagnetic waves. The universe has been quietly receiving our introduction for 100 years. Whether anyone is listening remains for now one of the most open questions in all of science. Water is everywhere in the universe. Not only on Earth, not only in the frozen reserves of comets and asteroids, water in its various forms has been detected throughout the galaxy and beyond. Water ice on the moons of Jupiter and Saturn, water vapor in the atmospheres of distant planets, water molecules drifting in the cold clouds of gas between the stars. A cloud of water vapor discovered surrounding a quasar 12 billion light-years away, holding more water than 140 trillion times the volume of Earth's oceans. Water is not unusual. Water is the universe's most common complex molecule because hydrogen and oxygen, the elements that make it, are among the most abundant in existence. This changes something about how we think about life. If water is common, and if water is, as far as we know, necessary for life as we understand it, then the conditions for life are not as rare as they once seemed. The ingredients are distributed widely, patiently across the cosmos. We are not an anomaly in a dry universe. We are wet in a universe that is in many places also quietly wet. The ocean is not ours alone. It is a pattern the universe returns to again and again, wherever the conditions allow. There is something quietly counterintuitive about the night sky that most people never think to question. The stars appear to move. Over the course of a night, they rise in the east and set in the west, tracing slow arcs across the sky the way the sun does during the day. The entire celestial sphere appears to rotate slowly, steadily, carrying every star and planet and the moon along with it, pivoting around a fixed point in the north that happens to sit very close to the star we call Polaris. But the stars are not moving, not in any meaningful sense relative to each other, not on the timescale of a single night. We are. The Earth is spinning one full rotation every 24 hours, and what we perceive as the movement of the sky is entirely our own motion, translated into the apparent movement of everything above us. We are the ones turning beneath the stars. The stars hold still, and we, sitting quietly, lying still, feeling entirely motionless, are in fact rotating at roughly 1,000 miles per hour at the equator. Stillness is relative. When you feel most at rest, you are moving. When the sky seems to be turning, it is you who are turning. The universe sits patient and steady, while the world carries you through it slowly through the night. Right now, somewhere on Earth, there are thousands of people awake in the dark, doing something that has been done for as long as humans have had instruments to do it with. They are watching the sky. Professional astronomers at observatories perched on high mountains where the air is thin and steady. Graduate students calibrating data in control rooms lit only by monitors. Amateur astronomers in backyards, in fields, in desert clearings, with telescopes of every size pointing at the same sky that sits above you now. They are spread across every continent, speaking dozens of languages, working on questions ranging from the nature of dark matter to the weather on planets orbiting distant stars. They are all looking at the same sky you are under. They are asking questions that have no answers yet, not because the answers do not exist, but because the instruments to find them are still being built, the mathematics still being worked out, the data still being gathered, one photon at a time. You are not alone under that sky. You are part of a vast, quiet, ongoing conversation between humanity and the dark, a conversation that has been running without interruption since the first person looked up and wondered what was there and has never once arrived at an ending. The sky is the oldest thing we have ever talked about, and we are still talking. For several years, a star at the shoulder of Orion has been behaving strangely. Betelgeuse, one of the brightest stars in the night sky, a red supergiant so large it would swallow the orbit of Jupiter, began dimming noticeably in late 2019. It dimmed more than it ever had in recorded observation. Astronomers called it the Great Dimming. Some spoke carefully about what it might mean. The possibility, always framed cautiously, always hedged with uncertainty, was that Betelgeuse might be nearing the end of its life. Betelgeuse is a star expected eventually to end in a supernova. When it does, it will be visible from Earth in daylight for weeks, outshining the full moon at night. It will be one of the most dramatic astronomical events in recorded human history. But soon, in stellar terms, means something different from soon in human terms. Betelgeuse may explode in 100 years or 100,000 years or more. The dimming turned out to be caused by a surface eruption that sent a cloud of dust outward, temporarily obscuring part of the star's light. It has since brightened again. It is still there in Orion's shoulder, burning as it has always burned on a timeline entirely its own. The universe does not post notices. It simply continues and occasionally gives us something to wonder about. Our solar system is not standing still. The sun, carrying all its planets and moons and asteroids and comets with it, is orbiting the center of the Milky Way at roughly 515,000 miles per hour. At that speed, a single orbit, one full trip around the galactic center, takes approximately 225 million years. The last time our solar system was in the position it occupies right now, the Triassic period had just begun on Earth. Dinosaurs had not yet appeared. The continents were arranged differently. The oceans were in different places. The atmosphere had a different composition. The first mammals were tens of millions of years in the future. One galactic year ago, the world was almost unrecognizable. And yet here we are, returned not to the same neighborhood exactly because the galaxy itself has changed, but but to the same position in the orbit, the same angle relative to the galactic center, carrying a planet that has changed almost beyond comparison from what it was the last time this position was occupied. The galaxy keeps its own calendar. We have completed 1 year of it in the time it took the Earth to go from the Triassic to tonight. In the distant universe, in the early epochs when the cosmos was young and dense and extraordinarily energetic, there existed objects of almost incomprehensible luminosity, quasars. A quasar is powered by a supermassive black hole at the center of a young galaxy, actively consuming vast quantities of gas and dust. As the material spirals inward, it heats to temperatures that release energy across every wavelength: radio waves, visible light, ultraviolet, X-rays in quantities that can outshine an entire galaxy of 200 billion stars by factors of hundreds or thousands. The most luminous quasars ever observed are so bright they can be detected across most of the observable universe, their light traveling for billions of years before reaching our instruments. They are windows into the early universe because the light we see from them left when the cosmos was young, and what we observe is not what they are now, but what they were then. Most large galaxies, including our own, are thought to have a supermassive black hole at their center. The Milky Way is relatively quiet now, but the evidence suggests it was once far more active, that long ago when the universe was young and gas was plentiful, the center of our galaxy blazed with quasar-like activity. We live in the quiet aftermath of something that once burned extraordinarily bright. The moon, seen from Earth, appears smooth at a distance, a pale disk softly lit, familiar as anything in the night sky. Up close, its surface tells a different story. The lunar regolith, the layer of material covering the moon's surface, is made of fine, jagged, glassy particles, the product of billions of years of meteorite impacts, grinding rock into powder. Unlike sand on Earth, which has been worn smooth by water and wind, lunar dust has never been touched by either. Its particles are sharp-edged, angular, electrically charged by the solar wind. They cling to everything they contact. They scratch. They were one of the unexpected challenges of the Apollo missions, getting into suits, into instruments, into everything. The moon has no atmosphere, no weather, no erosion in any familiar sense. A footprint left on its surface today will still be there in 1 million years, preserved exactly as it was made, unless a meteorite happens to land on it. Those footprints are still there now. The impressions left by 12 people who stood on another world between 1969 and 1972, still present, still sharp-edged in the dust, waiting in the silence. The moon holds what it receives in the dark indefinitely. Something is gathering itself right now in a cloud of gas and dust somewhere in the galaxy. Slowly, over millions of years, gravity is drawing that cloud inward. The center is becoming denser, warmer. Pressure is building. The cloud is beginning to rotate, the way all collapsing clouds do, conserving momentum as it shrinks. A disk is forming around the growing center. In the disk, small clumps of matter are beginning to attract more matter. A star is being born, not quickly, not dramatically. The way all important things happen slowly, quietly, without announcement, driven by the simplest of forces operating over the longest of times. By the time the core is dense and hot enough to ignite nuclear fusion, millions of years will have passed. By the time the star settles into the long, steady burn of its main sequence, life millions more. Everything that will ever circle that star is already there in the disk, waiting to become itself. This is happening right now in dozens or hundreds of places across the galaxy simultaneously, with no observer, no witness, no audience. Just matter and gravity and time doing what they have always done quietly in the dark, because that is what they do. Night has a sound. Not the absence of sound, actual sound, specific and old, the kind that has been here long before the first human ear existed to receive it. The low movement of wind through grass or leaves. The creak of trees cooling after a warm day, their wood contracting slowly as the temperature drops. The calls of creatures, owls, frogs, crickets, nightjars, whose voices are shaped specifically for the dark, timed to a world where the sun has stepped back and left them room. These sounds are not incidental to the night. They are the night in the register that hearing can reach. They are the acoustic texture of a planet doing what it has always done in the hours between dusk and dawn, running its quiet processes, cycling its chemistry, resting some systems while continuing others. The night is not a pause in the world. It is a shift in which parts of the world are most audible, a different layer rising to the surface when the louder daytime layer subsides. Right now, wherever you are, the night is sounding itself. Even in the silence that surrounds you, something is making a sound, and it has been making that sound or a sound very much like it every night since, long before anyone was there to call it beautiful. On a clear, dark night, far from any city, the Milky Way does something that most people, who have only seen it in photographs, are not prepared for. It casts a shadow. Not obviously, not dramatically, but measurably, perceptibly. If the night is dark enough and the eyes have had enough time to adjust, the combined light of 100 billion stars diffused across that pale band overhead is bright enough to produce a faint shadow on a white surface held beneath it. Your own shadow cast, not by the moon, not by a lamp, but by the collective light of the galaxy. Standing in a field under the Milky Way on a moonless night, you are standing in the light of 100 billion suns, each one so distant that its individual contribution is invisible, but together producing enough light to mark where you stand. There is something in that which the mind keeps returning to, the light of something incomprehensibly vast, traveling incomprehensibly far, landing gently enough to barely reach you and still reaching you. Still enough to mark your presence in the dark. Even at that distance, even that thinned, the light still knows you are there. The moon is leaving. Not quickly, not in any way you would notice in a lifetime, or in many lifetimes. But every year, the moon moves approximately 1.5 inches farther from the Earth, pulled gradually outward by the same tidal forces that it exerts on our oceans. Over billions of years, this adds up. When the moon first formed, likely from a collision between the young Earth and a Mars-sized body early in the solar system's history, it was much closer. The tides it raised would have been enormous, the nights it lit far brighter. It has been slowly drifting ever since, settling into a more distant orbit the way things sometimes do when the initial intensity of an encounter fades. The moon was here before anything complex lived on Earth. It has been a companion to every form of life that has ever existed on this planet, regulating tides, stabilizing Earth's axial tilt, influencing the rhythms of countless species, including our own. It is still here, still present, still large enough in the sky to move the oceans. It is simply very slowly finding its own distance, the way companions sometimes do, not leaving, just settling into the space that feels over time most naturally theirs. There is a rhythm in you that is older than your name. Your heartbeat, that steady, patient percussion that has been keeping time since before you were born, sits at a frequency that scientists have found echoed in a loose and remarkable way in the pulsation of certain variable stars. Not identical, not synchronized, but occupying a similar range of rhythmic periodicity when the stellar oscillations are translated into human-scale time. No one is claiming the universe has a pulse in the way a body does. No one is saying the stars are alive in the way you are alive. But the mathematics of oscillation of things that expand and contract, compress and release, build and subside, appears to repeat across scales, in ways that continue to quietly surprise the people who study it. Your heartbeat is a biological rhythm, shaped by evolution, kept by muscle, fed by iron from dead stars. And somewhere out there, a star is breathing in a rhythm that if you slowed one down or sped the other up, would not sound entirely unlike the other. The universe seems in places to keep a similar kind of time to living things. Not because it is trying to, but because the mathematics of rhythm does not seem to care very much about scale. It finds its patterns wherever it can, in stars and hearts alike, in the dark and in the body, without distinction. The universe has a preference for certain shapes. Not a conscious preference, not intention, not design, but a structural tendency that appears again and again at different scales and in different materials. Spirals appear in galaxies and in nautilus shells and in the arrangement of seeds in a sunflower. Branching structures appear in river deltas, and in the veins of a leaf, and in the bronchial passages of a lung, and in the filaments of the cosmic web. Spheres appear wherever gravity acts on matter with equal force in all directions, in stars, in planets, in raindrops, in soap bubbles. Galaxies that have experienced collisions take on forms that defy easy description: rings, lenses, teardrops, long streaming tails of stars, pulled out by tidal forces, frozen in shapes that will take hundreds of millions of years to resolve into something more settled. These collisions are not violent in any human sense. They happen slowly enough that individual stars almost never actually collide. The distances between stars within a galaxy are so vast that two galaxies can pass through each other like two swarms of fireflies interpenetrating in the dark. Their shapes distorted by gravity, their stars redistributed, their futures permanently altered. The universe makes its shapes out of time as much as matter, and the shapes it returns to again and again suggest something underneath a grammar of form that does not vary with scale, only with material and time. The body knows the dark. This is not a metaphor or a comfort offered without basis. It is physiology. In the absence of light, the brain begins producing melatonin, a hormone that signals the body to lower its temperature, slow its metabolism, reduce alertness, prepare for the deepest kind of rest. The eyes, already widening their pupils to receive what light remains, send signals to the brain that shift its activity away from the analytical, language-heavy processing of waking life towards something slower and more associative. The nervous system in darkness does not become less active, it becomes differently active. The parts of the brain associated with default mode, with memory, with imagination, with the loose, wandering quality of thought that visits just before sleep, become more prominent. Connections are made that the busy-lit, stimulated daytime brain tends to overlook. The dark is not where the mind goes quiet, it is where the mind goes soft. And soft, it turns out, is a different kind of thinking, not worse, not less capable, just oriented toward different things, toward integration, toward meaning, toward the kind of understanding that does not arrive as a conclusion, but as a feeling that something has settled into its right place. This is what is happening in you right now if you are letting it. In ancient Egypt, the sky was not a backdrop, it was a participant. Temples were built, not randomly, but precisely aligned to the rising or setting of specific stars, so that on particular days of the year, the first lighter star would travel down a long stone corridor and illuminate the innermost sanctuary. The face of a god carved in darkness for most of the year would be touched by starlight on the one morning it was designed to receive it. At Abu Simbel, the great temple of Ramesses, the second 2 days each year, around the 20th of February and the 20th of October, sunlight penetrates the full length of the temple and illuminates 3 of the 4 statues in the innermost chamber, leaving only the statue of Ptah, god of the Bing, underworld in shadow. This was not accident. It was engineering carried out without modern instruments, using observation and mathematics, accumulated over generations. The sky was a clock, a calendar, a religious text. The stars were not watched from a distance. They were built into the walls. People have always found ways to bring the sky inside, to make a home that remembers what is above it, that marks the moments when the two worlds briefly touch. There is something the stars offer that does not require understanding or knowledge, or even full wakefulness. You do not need to know the name of a star to be held by its light. You do not need to understand nuclear fusion to feel something shift when the sky opens up on a clear night and the full weight of it becomes visible. You do not need to know the distance to feel the distance the body registers it before the mind has finished forming a thought about it. This is one of the things that separates the night sky from almost every other experience available to a person. It does not ask anything of you. It does not require preparation or expertise, or even attention, not really. It simply exists, overhead, available, indifferent, in the most generous sense of the word. Not cold, not hostile, just present, whether you are looking or not. And when you do look, when you let the eyes go soft and the thoughts go quiet, and simply receive what is there, something arrives. That the daytime with all its noise and demand and useful urgency rarely delivers. A feeling of proportion, of being the right size for what you actually are, of the relief that comes from remembering without being told, that most things are larger than your worries and older than your fears. Some things reach us before our minds can name them. The night sky has always been one of those things. Jupiter's great red spot is a storm. Not a storm in the sense of something passing through a storm, in the sense of something that has been continuously present, continuously spinning for longer than any human institution has existed. Current estimates suggest it has been visible for at least 350 years, since astronomers first began recording it in the 17th century. Some believe it may be significantly older. It is a high-pressure system rotating counterclockwise, driven by the temperature differential between Jupiter's cloud layers. At its largest, it was wide enough to hold 3 Earths side by side. It has been shrinking in recent decades. No one is entirely certain why, but it remains for now the largest storm in the solar system. 350 years. While that storm has been spinning, humans have built and lost, empires developed entire branches of mathematics, learned to fly, split the atom, and sent machines to the edges of the solar system. Through all of it, the great red spot kept turning. It did not notice any of it. Some things in the universe operate on a patience so vast it makes history feel like an interruption, and they spin on indifferently in the dark of the outer solar system, keeping their own time. In the outer solar system, far from the warmth of the sun on moons, where the temperature falls to nearly 200 degrees below zero, it snows. Not water, snow. On Triton, Neptune's largest moon, nitrogen and methane condense out of the thin atmosphere and settle onto the surface as frost. On Pluto, nitrogen snow falls in the long polar winter and accumulates in drifts across the dark frozen plains. On Titan, methane rain and snow cycle through the atmosphere in a pattern eerily similar to the water cycle on Earth, just made of entirely different molecules in conditions no human body could survive for a moment. Snowfall is not a thing that belongs only to Earth. It is a process condensation, precipitation, accumulation that happens wherever there is an atmosphere and a temperature cold enough for something to change phase from gas to solid. Change the molecule, change the temperature, and the process persists. Somewhere, right now in the dark of the outer solar system, something is falling softly through a thin and frozen atmosphere and settling onto a surface that has never been touched by sunlight warm enough to matter. And it is falling the way snow always falls, slowly and without sound, covering everything gently and without preference. The universe finds ways to be gentle even in its most inhospitable places. The word disaster carries a history worth knowing. It comes from the Italian disastro, which comes from the Latin astrum star, disastro, bad star. For thousands of years across many cultures, the stars were believed to exert direct influence over human affairs. A comet appearing in the sky was not a neutral astronomical event. It was a message, a warning, a portent of something that was coming: plague, war, the death of a king. This belief was not superstition in the dismissive sense. It was pattern recognition operating on incomplete information, an entirely human and entirely reasonable response to living in a world where the sky was one of the few things that behaved with predictable regularity and where the appearance of something unexpected in it naturally seemed significant. Astrology, horoscopes, the careful charting of planetary positions, these are the ancestors of astronomy, born from the same impulse, the desire to find meaning in the movement of lights in the dark. The impulse was not wrong. It was early. It was feeling towards something real, using the tools available. We kept looking. The tools changed. The questions sharpened. But the original impulse, the sense that the sky is speaking, that it matters, that what is above us is connected to what happens below, that has never entirely left. And perhaps it should not. The sky and the earth are connected, just not in the way the ancients thought. Deep in the cold between the stars, in the molecular clouds where new stars have not yet formed, scientists have found something extraordinary. Complex organic molecules, not just simple compounds, but molecules with dozens of atoms, arranged in structures that on Earth are associated with the chemistry of life. Amino acids, the building blocks of proteins, have been found in meteorites, sugars, alcohols. Nucleobases, the chemical letters that make up the alphabet of DNA and RNA. These molecules form spontaneously in the cold and the dark on the surfaces of dust grains driven by ultraviolet radiation and cosmic rays and the slow chemistry of interstellar ice. They are not made by life. They are made by physics and chemistry operating without direction, producing complexity from simplicity, because the laws of chemistry tend in certain conditions toward complexity. This does not prove that life exists beyond Earth, but it means the raw materials for life, the starter ingredients, the first steps in the recipe are not rare. They are common. They are distributed across the galaxy in the same gas clouds that eventually collapse into stars and planets. Life, if it exists elsewhere, would not need to start from scratch. The chemistry would already be waiting on the surface of every dust grain, in every cold and patient corner of the dark, far from any star in the vast stretches of intergalactic space where nothing burns and nothing warms, and there is almost nothing at all. The temperature of the universe settles to a number so close to absolute zero, it is almost indistinguishable from it, 2.7 degrees above absolute zero. That is the background temperature of the universe, the temperature of the cosmic microwave background radiation, the ancient light left over from the early universe now cooled by billions of years of expansion to something barely above the coldest possible state of matter. Absolute zero is not simply very cold. It is the point at which atoms would stop moving entirely, the complete absence of thermal energy. Nothing in the universe has ever reached it. The universe itself approaches it slowly as it expands and cools over billions of years, but it has not arrived there and may never. Warmth in this context is not ordinary. Warmth is the exception, the rare condition, the local anomaly produced by stars and the planets that circle them. The universe is almost entirely cold. Every fire, every warm room, every body temperature, every summer afternoon on Earth is a small and temporary deviation from the overwhelming coldness of what most of the universe actually is. You are warm in a cold universe. That is not nothing. That is, in fact, quite extraordinary. A small flame, lit against an almost infinite cold, burning quietly in the dark. Among the stars, there are some so ancient they approach the age of the universe itself. HD 140283, a star in the constellation Libra, is estimated to be approximately 13.8 billion years old, almost exactly as old as the universe is believed to be. It formed from the very first generation of stellar material, enriched only by the deaths of the first stars. It contains almost no metals in astronomical terms. Elements heavier than hydrogen and helium, because when it formed, almost none existed yet. It has been burning steadily and quietly since before the Milky Way fully formed, since before the Earth was a thought, since before almost everything that exists in the observable universe had taken the shape it has now. It has watched in the most passive sense the entire history of cosmic evolution, the formation of galaxies, the birth and death of billions of stars, the slow assembly of the conditions that eventually produced a small planet with liquid water and something alive on it. It is still burning now. Dim, cool, carrying almost nothing heavy in its spectrum, a remnant of the universe's first generation still present, still going in no apparent hurry. The oldest things in the universe do not announce themselves. They simply continue. You are one of the rarest kinds of thing the universe has produced. Not rare because you are exceptional, in the way a prize is exceptional. Rare in a deeper, stranger sense. The universe is overwhelmingly made of hydrogen and helium, simple, ancient, abundant. Complex chemistry requires heavier elements, and heavier elements require stars to make them, and supernovae to distribute them. Planets with liquid water require a star of the right size and stability, and a planet at the right distance. Life, as far as we know, requires all of that, plus time, plus chemistry, plus conditions that have to persist long enough for something simple to become something complex. And a mind that can look up at the sky and comprehend, even dimly, even imperfectly, the scale of what it is seeing. that requires everything else, plus billions of years of evolution, plus the development of language and mathematics, and the passing of knowledge from one generation to the next. The universe is 13.8 billion years old, and vast beyond any number that fits comfortably in a sentence. And in all of that, the ability to look up and ask, what is there to genuinely wonder, to hold the question with curiosity rather than fear, is among the rarest arrangements of matter that has ever existed. You are that arrangement, right now. Looking up or remembering looking up or simply holding the thought of a sky full of stars. That is worth sitting with for a moment. A black hole does not reach out and pull. This is one of the most common misunderstandings about one of the most misunderstood objects in the universe. A black hole does not grab. It does not extend some force outward to capture what passes by. What it does is curve space itself, bend the geometry of the region around it so completely that all paths, including the path of light, lead inward. Imagine a heavy ball placed on a stretched rubber sheet. The sheet curves downward around the ball. A marble rolled nearby follows the curve of the sheet, not because the heavy ball is pulling the marble, but because the shape of the surface has changed. A black hole does this to space itself to 3 dimensions and time simultaneously, curving them inward so deeply that beyond a certain boundary, the event horizon, there is no path that leads anywhere but in. Inside that boundary, all directions lead toward the center. There is no sideways. There is no turning around, not because of force, but because of geometry. The universe at its extremes does not exert force in any familiar sense. It changes the shape of the space in which things move, the way a valley gathers rain without reaching up to pull the clouds down. Everything simply follows the shape of what is there. Gravity is not a hand. It is a landscape. The universe is roughly 13.8 billion years old, and it may be one of an uncountable number of universes. This is not established science in the way that the age of the universe is established science. It is a serious hypothesis, several serious hypotheses in fact, held by serious physicists, arising from the mathematics of inflation theory and quantum mechanics. The multiverse, as it is sometimes called, is not a fringe idea. It is a frontier idea which is different. It sits at the edge of what can currently be tested, which means it sits at the edge of what science can currently confirm or deny. If the universe began with a rapid expansion called inflation, the mathematics suggests that inflation may have produced multiple regions of space, each with potentially different physical constants, different laws, different possibilities. In some of those universes, the conditions for stars and planets and chemistry may not exist. In others, entirely different kinds of complexity may have arisen. We cannot know. We may never be able to know. The other universes, if they exist, are beyond any horizon we could ever reach. But the possibility held carefully without overclaiming changes something about how this universe feels. Not smaller, somehow more particular. More specifically, itself, more precisely, the one in which the conditions happen to align for something as quiet and unlikely as a person in the dark wondering about it. Venus is often called Earth's twin, but it is Mars that has recently received more of humanity's attention, and Mars has not made it easy. The atmosphere of Mars is thin, less than 1%. The density of Earth's made mostly of carbon dioxide, cold enough on most nights to freeze carbon dioxide itself into dry ice at the poles. The surface is bathed in ultraviolet radiation that would be lethal to most life as we know it. Dust storms can last for months. The average temperature hovers around 60 degrees below zero. And yet rovers have driven across it. Helicopters have flown in its thin air. Instruments have tasted its soil and analyzed its atmosphere and drilled into its rock. In 2021, a small helicopter called Ingenuity made the first powered flight on another planet, a moment that was in its quiet way as extraordinary as the first flight at Kitty Hawk, just witnessed by cameras on a rover rather than by people on a beach. Mars was warmer once. It had liquid water. It had a thicker atmosphere before its magnetic field weakened and the solar wind stripped it away. The history of Mars is in part a history of loss, of what a planet becomes when the conditions that protect it gradually fade. It is also still a place where human machines are working right now, making tracks in ancient dust, measuring, listening, sending signals home. Even as you rest here, something remarkable is happening in the sky above you that requires no telescope, no instrument, no special knowledge to appreciate, only a clear night and a willingness to wait. In the right conditions, far enough from city light on a mountain, or in a desert, or anywhere the sky has been allowed to stay truly dark, the Milky Way appears not as a faint smear, but as a full luminous river of light stretching from horizon to horizon. Its structure is visible, dark lanes of dust cutting through the brightness, brighter regions where the star density increases, fainter regions where it thins. And in that light, if the night is dark enough, you cast a shadow, your own silhouette, projected by the combined light of 100 billion stars, onto whatever surface is behind you. Not moonlight, not a lamp, the galaxy itself printing the shape of you in faint light against the ground. There is almost no way to prepare for what that feels like the first time it happens. The mind knows the fact. The body receives it differently, a sudden and quiet recalibration, a sense of being genuinely physically connected to something that the mind usually keeps at a comfortable conceptual distance. The galaxy is not only something you look at. On the right night, it is something you stand inside of, and it knows exactly where you are. The moon has been moving away from Earth for as long as it has existed. But there was a period early in Earth's history when it was so close that the tides it raised were enormous walls of water moving across a young, mostly ocean-covered planet with a force that may have played a significant role in the chemistry of early life. The energy transferred between Earth and Moon in those early tidal interactions was vast, shaping coastlines that no land creature had yet evolved to walk along. The Moon's gravity also stabilizes Earth's axial tilt, the angle at which the planet leans as it orbits the Sunday. Without that stabilization, Earth's axis might wobble more dramatically over time, producing climate swings far more extreme than anything in the geological record. The Moon, in its slow drift outward, has been holding Earth steady, keeping the seasons within a range that allows the kind of long-term climate stability that complex life seems to require. It does this without knowing it. It drifts because of physics. It stabilizes because of physics. It has no intention toward us, no awareness of what it does. And still the seasons come and go in their familiar order. The axis holds its familiar angle. The years follow each other in a pattern regular enough to build a civilization on. All of it quietly underwritten by a companion that is slowly and without intention finding its own distance. Even now, in the spaces between the stars, in the cold and the dark, far from any warmth, chemistry is happening. Molecules are forming on the surfaces of dust, grains, complex ones, patient ones, molecules that have no urgency and no destination. Water ice mixed with methane and ammonia and carbon dioxide, building up layer by layer on particles so small they float on the pressure of starlight. Ultraviolet radiation from distant stars breaks and reforms chemical bonds, slowly assembling more complex structures from simpler ones. Among these molecules, scientists have found glycine, the simplest amino acid, one of the building blocks of proteins. They have found sugars. They have found molecules that on Earth are found in living cells, not because life made them, because chemistry operating without direction, in the cold and the dark, tends in certain conditions toward the same structures that life later found useful. The universe has been practicing the chemistry of life for billions of years, in places where no life exists. It has been running the same reactions, assembling the same building blocks, over and over in molecular clouds, scattered across the galaxy. Patient as only something without awareness of time can be patient. If life began on Earth, partly from the chemistry that arrived on comets and asteroids, then in some sense, life did not begin on Earth at all. It began out there in the cold, in the dark, long before any world existed to receive it. The universe was already trying before there was anywhere to try. Stars do not all end the same way. The ending of a star depends almost entirely on how much mass it began, with the fact that gives the universe a quality of quiet fairness, as though each star contains from the very beginning the shape of its own conclusion. A star like our Sun will swell gently into a red giant as its hydrogen fuel runs low, expanding until it swallows the inner planets, then shedding its outer layers in a slow, luminous cloud called a planetary nebula. One of the most beautiful structures in the galaxy, a soft shell of glowing gas, drifting outward while the core cools into a white dwarf. Gradual, quiet, taking billions of years to complete. A more massive star ends differently. It burns faster lives, shorter, and when its fuel is gone, it collapses in a fraction of a second and then rebounds in a supernova, a single moment of light visible across the galaxy, releasing more energy than the Sun will produce in its entire lifetime, scattering the heavy elements it has made into the space around it. Same process, same physics, different amounts of matter, and the ending is entirely different. Some things go gently over immense time, others end in a single, brilliant, unrepeatable moment. The universe does not rank these. It simply offers both, and lets the mass decide. The southern sky holds stars that no one in the northern hemisphere has ever seen with their own eyes. The Southern Cross crux, visible only from latitudes south of roughly 25 degrees north, has guided navigators for centuries, and appears on the flags of 5 nations. The Large and Small Magellanic Clouds, 2 small irregular galaxies that are the closest galactic neighbors to the Milky Way, hang in the southern sky like detached pieces of the Milky Way itself. Visible to the naked eye on a clear night, close enough that individual star clusters within them can be seen without a telescope. The Eta Carinae Nebula, the Omega Centauri globular cluster, a ball of roughly 10 million stars, so dense at its center that if you lived on a planet there, the night sky would be a blaze of starlight with no true darkness anywhere. Centaurus A, a galaxy with a dark lane of dust across its center, one of the brightest radio sources in the sky. These are not obscure objects. They are among the most remarkable things the sky contains, and an entire hemisphere of humanity living north of the tropics has never seen them with unaided eyes. The universe offers different gifts depending on where you stand. No single position sees everything. No single view holds the whole sky. That is not a limitation. It is an invitation to move, to travel, to remember that the sky is larger than any one place allows. Right now, in this moment, you are doing something your ancestors did in exactly the same way, with the same body, the same nervous system, the same widening pupils and slowing breath. You are receiving the night. The curiosity that brought you here to a quiet place, to a voice in the dark, to the thought of stars, is not a modern habit or a cultivated taste. It is one of the oldest things your body carries. The drive to look up, to wonder, to sit with questions that have no immediate practical answer. That impulse predates agriculture, predates writing, predates every institution and invention that defines what we call civilization. It is in the oldest parts of the brain. It is in the behavior of children before anyone teaches them to look at the sky. It is in the rock art of people who lived 40,000 years ago and carved star patterns into stone. It is in every culture that has ever existed on this planet. Every single one has a name for the stars, a story for the sky, a reason to look up. You inherited this. It arrived in you without being asked for. And it is alive in you right now, quiet and patient, the same instinct that has been looking up since the beginning of whatever we are. There is a telescope orbiting the Earth right now that can detect the heat of a bumblebee at the distance of the Moon. The James Webb Space Telescope, launched in December of 2021 and positioned approximately 1 million miles from Earth, carries a mirror 6.5 meters across, cooled to nearly absolute zero to reduce its own heat signature, allowing it to detect the faintest possible infrared signals from the most distant objects in the observable universe. In its first years of operation, it has imaged galaxies formed within the first few 100 million years after the beginning of the universe, the oldest light ever recorded by a human instrument. It has detected the atmospheric composition of planets orbiting other stars, reading the chemical fingerprints of worlds that are light years away. It has found water vapor, carbon dioxide, and other molecules in the atmospheres of distant worlds. It is by a meaningful measure the farthest seeing eye humanity has ever built, and it is open right now, in the dark a million miles away, gathering light from the edges of what can be seen, patient and cold, and extraordinarily precise, doing in the dark what human curiosity has always done, looking, waiting, receiving, whatever arrives. Somewhere right now it is the last hour before dawn. In that hour the sky does something it only does once each night. The stars that have been present since darkness fell begin almost imperceptibly to thin at the edges of the sky, not vanishing, just becoming slightly less certain, slightly less sharp as the atmosphere begins to catch the first suggestion of pass, sunlight still far below the horizon. The darkest part of the sky directly overhead stays dark the longest. The horizon begins first, a barely perceptible deepening of color, a blue that is not quite black, beginning to separate itself from black. This is the time astronomers call astronomical twilight. It is the hour when the sky is still dark enough for serious observation, but the night is beginning to let go of itself slowly without announcement, the way all transitions happen when they are allowed to happen at their own pace. Animals that wake at dawn stir in this hour. The first birds begin not in response to light, but in response to something more subtle, a change in the atmosphere itself, a signal older than vision. The night in this hour is already becoming something else, though it has not yet arrived there. It is still the night, and it is holding everything as it always does, quietly asking nothing in return. The stars do not need to be understood to be real. They burn whether or not anyone names them. They live and die on timescales that have nothing to do with whether any mind has ever turned toward them. The universe did not wait for consciousness before it began doing what it does. It was already ancient before the first eye opened on Earth, already producing light and complexity and the conditions for wonder, before there was anything capable of wondering. And yet here we are, the universe produced out of its own matter and its own laws, something that looks back at it, something that names the stars, measures them, tells stories about them, is moved by them at 11 o'clock on a quiet night. That did not have to happen. There is no law of physics that requires the universe to produce anything capable of noticing it. It did anyway. Whether that means something, whether it points toward anything larger than itself, is a question that science does not answer and perhaps cannot. But the fact of it, the sheer strange specific fact of a universe that generated something capable of being astonished by itself, sits quietly in the center of everything. The stars do not need to be beautiful, and they do not need to be beautiful to matter, and yet they are and they do, and you are here, and that is the whole of it. The sky keeps its gifts differently in different places. In the northern hemisphere, you have Polaris, the North Star, fixed above the pole, the one star that does not appear to move the anchor around which the entire night sky turns. In the southern hemisphere, there is no equivalent bright star above the South Pole. The southern sky turns around a point in the dark, an absence that navigators learn to use as precisely as any star. Different hemispheres, different gifts. Different seasons bring different constellations. Different latitudes open different windows in the sky. No single person, in a single lifetime standing in a single place, will ever see the whole sky. And perhaps that is the point. The sky is not something that can be finished. It is not a collection to be completed or a text to be fully read. It is a presence constant, available, inexhaustible, that offers something different every night to every person willing to look from wherever they happen to be standing. It has always been this way. It will continue to be this way, long after every name currently given to any star has been forgotten and replaced by names not yet invented. The sky does not run out. It simply continues patiently above wherever you are. Even now, as the breath slows and the body settles, you are not separate from what you have been thinking about. The same atoms that make up the stars are in you. The same forces that hold galaxies together hold the molecules of your body in their shapes. The darkness outside is the same darkness that fills most of the universe, not threatening, not empty, just the vast and patient medium in which all of this is happening. You are breathing in the dark, on a spinning rock circling an ordinary star in the outer arm of a spiral galaxy that is one of perhaps 2 trillion galaxies in the observable universe. That description is accurate. And it is also this: you are home. You are warm. You are resting. The night is doing what it has always done, and you are inside it, and that is enough. The distance between the cosmic and the immediate is not as large as it seems. The same universe that contains a magnetar and a quasar and the cosmic web also contains the particular quality of this quiet, this darkness, this moment of stillness before sleep. It all belongs to the same thing. You belong to the same thing. Everything you have visited tonight, the ancient light, the patient stars, the hidden oceans under ice, the rhythm of variable stars, the iron in your blood, the shadow cast by 100 billion suns, was always already here. It did not arrange itself for tonight. It did not wait for anyone to notice. The universe has been doing all of this, the burning, the cooling, the forming, the drifting, the colliding, the slowly becoming, for nearly 14 billion years in the dark, with no audience, with no need for one. And for a small and fleeting moment, you were the audience. You turned toward it. You let some of it in. You held the questions without needing the answers. And you stayed with the dark long enough to find something in it that felt, despite everything, like company. That is not a small thing. In a universe that is mostly cold and mostly empty and mostly unobserved, the act of noticing, of turning toward the vast and the ancient and the quietly astonishing and saying simply, "I see you," that is something the universe did not have to produce. And it did. You are one of the ways the universe has learned to know itself, briefly, warmly, in the dark. The night will end as it always does. Slowly at the edges, first the dark, thinning into color at the horizon, the stars near the east becoming uncertain, the sky above still holding its depth, while the world below begins to remember itself. It will happen without announcement, without hurry, the way all true transitions happen, not at a single moment, but across a long, soft gradient, from one thing to the next. The stars will not vanish. They will only become quiet again, stepped back behind the brightness of a closer sun. Still there, still burning, still sending their light in every direction, including toward this small and particular world, where for a few hours someone was awake and paying attention. They will wait. They are very good at waiting. They have been doing it since long before there was anyone to wait for, and they will continue long after. Patient, indifferent, burning in the dark, holding their positions in a sky that turns and turns and carries everything through another night, another dawn, another day. Whatever you carry with you from here, whether it is a single image, a single fact, a single moment of feeling genuinely small and genuinely held at the same time, carry it gently. It came from a long way away. It has been traveling toward you for longer than either of us can say. I hope you sleep well and dream softly. Good night.